All right, hello. First of all, I'd like to acknowledge the traditional owners of the land on which we gather today. I'd also like to pay my respect to elders past and present. Today's talk, I'll be sharing a story of we at Audinate, where we transitioned from FreeRTOS to Zephyr RTOS. So basically a product refresh journey where we've leveraged the open source community provided by Zephyr RTOS to reach next generation audio networking. My name is Elton. I am a research engineer at Audinate, where I focus on embedded systems and system software. I've been there for 2 and a bit so years. And for those who don't know who Audinate is, if you've been in the pro AV industry a little bit, or you've worked with AV system before, you might have heard of Dante. Audinate is basically the maker of Dante, which is the professional audio and video networking standard that people use. So, before we dive into the product refresh story, I'd like to cover a little bit on what Dante is, how Dante works, and what we do. So, Dante, basically what it tries to do is it transforms traditional audio cabling problems for pro AV setups into a networking problem. In the traditional setups, you would basically have point-to-point connections between audio devices, and these would basically have cablings that is specialized, very expensive, and single purpose. When you have a massive AV system where, across venues, you have front of house, you have basically a big setup with huge amount of devices such as speakers, microphones, and mixers. In order to do any changes, it would be a really labor-intensive and expensive task. And when the distance goes long, when you have two devices that has a large distance, it is more sensitive to noise when the distance goes up. So what Dante does is it replaces all of this with networks. We connect all of these audio devices directly to your network switch, which forms a Dante network on your LAN, and you'd be transmitting these audio through network packets and the controlling as well. So this makes the routing of audio, the connections from device to device, a software problem. And we basically, Dante provides low latency, uncompressed audio routing in a synchronized fashion. So this is very important because in the pro AV space, if you do have glitches in audio or audio packet loss, you basically have a big trouble. So where is Dante used? Who uses Dante? Well, at this point in 2024, we have more than 4,000 products that from manufacturers that is Dante enabled, and we have more than 600 Dante manufacturers that produces products based on Dante. And it is used in many scenarios in the world. For example, Sydney Opera House. So Sydney Opera House uses Dante to do their systems. Recently, they have a fixed setup. There's also Sydney Trains. The announcement systems at Sydney Trains is basically a Dante system. And if you've been in recording studios, you'd most likely heard of Dante because it is really widely used. And it's not limited to just these scenarios. It's basically used in all sort of situations where you need to deliver audio from A to B. And it's not only limited to audio, we also gone into the video space where we do video over IP as well. And in fact, I believe in today's venue, we also use Dante in our setup. So that is kind of interesting. And in FY23, we've actually delivered 1 million devices in that single year, which is a really big milestone for us. So what do we actually sell? What are the Dante products that Audinate produces? So there's 2 categories of Dante products that we sell. So the first one would be products for end consumers. So these would be people who actually works with the Dante system, configuring and setting up your AV systems using Dante. So the first one would be system software, where you use our software systems to control the configuration of your audio from A to B, from your mixer to your speakers and so on. We also have network adapters. So these are called AVIOs. So AVIOs are basically little boxes where you can retrofit your legacy devices, such as your old speakers that has a XLR interface, and you can connect it through the Dante AVIOs and basically pipe audio in and out of Dante to your legacy gear. There's also Avios for Bluetooth as well as USB-A, USB-C. So for the Bluetooth ones, you can use your phone to connect to that device and play audio into the Dante network from your phone. And for the USB ones, if you plug it into your laptop or your PC, it shows up as an audio sound card where you can do audio playback into the Dante network as well. And it's not only limited to all those. We also have PC software and cloud software where examples like Dante Virtual Sound Card, which is a software that you can install on your system and basically have a direct interface into Dante. And that is the first category of where we sell products into end customers, consumers. And then there's another category where we sell products to manufacturers, which are OEMs who take our modules or our products and build systems on top of it. So it goes into two main categories, the audio space and video space. And for both of them, we have hardware solutions and software solutions. Today we'll be focusing a little bit more on the audio space because the product refresh, the main character over here we're going to talk about is an audio device. So for hardware, there's three main platforms, the Brooklyn, Broadway, and Ultimo. So these are basically chips, cards, and modules that we would sell to OEMs, and they will basically build products such as mixers and microphone systems and speakers on top of it. We also sell software. So one example is the Dante Embedded Platform, which is a Linux-based containerized software package where you can run on anything that runs Linux. We support x64, ARM32, and ARM64. There's also Dante IP Core, which is basically IP designs that is intended for customers to put onto their FPGA fabric. So there's no limitations on which particular hardware platform that you're using. So diving into today's topic, so chips, modules, cards, and modules. So talking about Brooklyn, Broadway, and Ultimo, it's basically different Dante hardware solutions providing different capabilities for audio routing. On the top, we have the Brooklyn, which delivers up to maximum 64 times 64 channels. And by that would mean 64 transmitting channels and 64 receiving channels. So imagine your traditional speakers where you have two XLR cables. That is basically two channels. So 64 really goes up in scale. And the Brooklyn is basically an FPGA-based. So it's basically a little card module that has a mini PCI interface and basically has a FPGA on it. It used to be a Spartan 6 that runs a microBlaze soft-core processor, as well as the hardware design, the IP for Dante. And since it has higher channel counts, it's really suitable for OEMs who want to build stuff like mixing consoles, the one over there, and DSP machines. So one of the examples is the Yamaha DM7 mixer. So Yamaha is one of our early day customers who've integrated Dante as an early customer. Going down the stack to the far end, we have the lower cost solution, which is today's main focus, Ultimo. Ultimo delivers up to 4 times 4 channels, which is 4 channels of transmitting audio and 4 channels of receiving audio. And this is a microcontroller-based solution where we have a little microcontroller that basically delivers this amount of channel count for audio routing. And it is really suitable for devices that doesn't require many audio channels, such as speakers and microphones. And as an example, we have, for example, the Fostex Dante speakers and the Audio-Technica Dante microphone, which is basically devices that you connect your network cable to your system and it would just pop up and do its work. So, focusing on Ultimo, let's start the refresh story. So, Ultimo, as we just mentioned, it's a microcontroller-based product, and it is considered as the low-cost Dante solution, which is built on top of a microcontroller plus a real-time operating system running on top of it. The real-time operating system that we run is FreeRTOS. For those who are not familiar with RTOS, real-time operating systems have a focus on real-time scheduling, and it's usually used on resource-constrained devices such as microcontrollers where Linux might be too big to run. So having a top-down view of the low-cost Dante stack, we have this. This is Ultimo. On the very bottom, we have the 32-bit microcontroller. So we have a single microcontroller that we work with. And on top of that, we have FreeRTOS, and then Dante as is on top of that, together with the OEM application that actually does the transferring of audio samples between the OEM side and the Dante world. So FreeRTOS is actually really bare bone. So this solution, this Ultimo product, is really have tight coupling between layers. Everything that we've built over the years, we have customized the drivers and implementations to improve the optimizations. And basically, through this process, we've realized that the porting effort is really significant. If we want to move onto a new platform, a new MCU hardware, it would be a lot of work. So in 2020, we've realized that, we're hitting resource limits. And by that, this is basically coming from the fact that we've added so many new features over the years, including audio encryption. So this is for audio confidentiality. We've also added functionality such as cloud connectivity that connects to our cloud solutions. We've also added new audio formats for audio routing. And all of those actually take up CPU time as well as memory footprints. So as we add new features, we've slowly realized that we're running out of space for the Ultimo product that we're running on that 32-bit ARM microcontroller. And at that point, we realized a product refresh is due. That was 2020. So, things were still okay. And we thought we started planning early and we thought we had plenty of time. However, that wasn't the case. So the next year, COVID was happening at that time, and then chip crisis happened. So in 2021, the global chip crisis really hit us in a few of our products, which has high dependency onto the hardware that we were working with, and Ultimo was one of them. Basically, the microcontroller that we were working with had supply chain uncertainties, and our vendor allocation for the chips were very dynamic. So we would only have month-to-month visibility towards how many chips we would be getting each month. So for 1 month, we might get chips, the Ultimo product is safe. For the next month, we would run out of chips and we can't sell any Ultimos. So that really got us thinking of, what if we can spin up the Ultimo product on different hardware, on different MCUs, and not tied down to one single platform? However, as mentioned, it was really hard because due to the tight coupling between each layer that we have in this digital stack. So the focus slowly shifted to the fact that we need to reduce our reliance on our single hardware portfolio and basically provide portability in each layer in order to support Dante running on real-time operating systems on different hardware. So that's when we also realized, we don't have plenty of time and really need to get started. And with that, we basically embarked on our journey on our product refresh for the Ultimo, which is the low-cost Dante. And there's essentially two parts to this task. So firstly, we have the microcontroller selection. In order to ease the pain from having supply chain uncertainties, we wanted to find an initial alternative to the microcontroller that we were working with that didn't have the supply chain uncertainties that we were facing. And with that, we also wanted to consider a few factors and selection criteria, including the technical criteria of having more flash, more RAM for future features, needing a Ethernet MAC as we rely on networking, I2S for audio, crypto acceleration hardware blocks for audio encryption, for audio confidentiality, and having a decent clock speed. And on top of that, there's also factors that comes in from the non-technical side, which are whether we have complete BSP support, whether the activities from vendors of fixing bugs and pushing upstreaming changes is very active, and more importantly, the price point and also the availability of chips. As for the RTOS, we also wanted to do a re-evaluation because our experience from the past, we want to move away from hard coding everything onto one single platform and become more hardware agnostic. So we've listed out a few points that we really wanted for a real-time operating system, and we started a re-evaluation of what's out there, what RTOS options do we have? Fast forwarding to 2024, we've recently came out with our first product based on the refresh, which is the Dante Pro S1. So different to what we had before for the Ultimo, this time we're running a Zephyr RTOS. And for the microcontroller, we're using a STM32 Nucleo H7. So this is very exciting. So now we want to look back at the process, the product refresh, the journey, and what made us decide we wanted to go with Zephyr. What are the risks, what are the benefits, and what went good and what was challenging. When we started looking at real-time operating system options, there were a few options that we were considering, and we later on decided with Zephyr RTOS mainly because one driving factor, it is vendor neutral. We used to use FreeRTOS, and the other considering option was ThreadX. FreeRTOS being the open source, sort of, the most widely used real-time operating system before, well, probably still is, was bought out by Amazon in 2017 as part of their cloud strategy. So cloud vendors, basically, in the cloud world, there's also IoT devices that want to connect to the cloud. And it made sense for Amazon to have steering capacity and stewardship over the future development of real-time operating systems. So, it made sense for them to buy FreeRTOS. For ThreadX, it was a closed source project. In 2019, it was bought out by Microsoft. And later, it got renamed to Azure RTOS. And recently, in 2023, November, it transitioned into an open source model under the stewardship of Eclipse Foundation. But at that time, it was basically FreeRTOS with AWS and ThreadX with Microsoft. And that made Zephyr RTOS a really nice option because the people behind the Zephyr project is the Linux Foundation. And they promote basically the project is steered by the community rather than a single entity of organization. So the technical steering committee is basically made up of maintainers, collaborators, and contributors, and these people are coming from the industry, so industry representations, hobbyists, and vendors. So there are actually a lot of interesting vendors that's backing the movement of Zephyr RTOS, including Intel, Nordic Semiconductor, and more. On top of that, there's also a very vibrant community. So for the Zephyr project, in order to get a new feature, you can either work on it yourself and upstream it. You can collaborate with the community. So this would usually be major features that's rolling out in future releases. You can request features that you want, or you can also outsource the development of features. And you can also, since there's a lot of vendors participating in the development of Zephyr, you can basically directly ask them to develop features for you. So you can talk to tool vendors, chip vendors, and yeah. And over the years, since Zephyr RTOS joined the Linux Foundation project in 2016, they have the highest average unique contributors and average commits per month over the years. So for us, looking at this, having a strong community and open source community is a really attracting factor when we were selecting our RTOS for the new Ultimo. Now, when we look at the other factors, including the cross-vendor support, off-the-shelf BSP completeness, as well as the features that Zephyr provides, it is actually pretty good. So Zephyr actually is, similar to FreeRTOS and other RTOS, is very cross-architecture. It supports most of the well-known ISAs, ARM32, ARM64, x86, x64, and RISC-V is behind it as well. So it is really cross-architecture and hardware agnostic. That's one of their focus. And with the amount of vendors that's supporting the project, basically there's more than 100 vendors that's officially participating in the community to support their boards. So there's a lot of off-the-shelf boards that basically just runs out of the box when you want to run Zephyr. On top of that, there's a lot of features that is included in the development of Zephyr. So unlike some of the other RTOS, which is more bare bone and simply a real-time scheduler, Zephyr actually puts in a lot of features in it, and there's a lot of basically support over applications. So you can quickly just spin up sample applications to evaluate the features that you want to test, evaluate the performance, and when you're implementing, you find that the drivers that, parts that you select, drivers are probably going to work out of the box. We were looking at exploring file systems, using file systems to store some of our files on the low-cost platforms, which is something that we haven't done in our previous project, Ultimo. And we quickly put together a demo, and it only took us a few days to put together the drivers, the file system, and it just works out of the box, even for the Flash that we were using. So, fast prototyping and feature evaluation is really attraction for us. On top of that, there's also a big focus, which is the modularity and portability, which comes back to whether we can become more hardware agnostic for the RTOS platform that we're working with. Looking at the Zephyr architecture, on the top we have the application layer, and below that, basically we have the Zephyr operating system services, not necessarily in the kernel space, but applications would basically talk to these services through high-level Zephyr APIs. And then below that, these would basically interface with a Zephyr kernel through the low-level Zephyr APIs. And below that, we have the hardware, which is separated by the HAL. So each layer has really fine-grained abstractions and no dependencies toward and hardware customizations directly cross layers. On top of that, Zephyr RTOS uses CMake for the build system, which is what we use in other projects as well. So it was really nice for us to really quickly take existing code, integrate it into the Zephyr project, and try and put it together. There's a concept in Zephyr RTOS called Zephyr modules. So being an RTOS and having so many features, all of these features and libraries, including the file system, networking, the HAL, third-party libraries, all of them are actually included into your Zephyr project as modules. So you can cleanly turn on, turn off, define configuration options, and include the things that you want for your particular project and exclude it as you want. This is really nice. And the configuration part is using kconfigs. One thing I wanted to raise is also the fact that Zephyr RTOS supports POSIX. This is nice because, as mentioned earlier, Dante has a wide range of support for platforms. We have desktop software, we have Linuxy code that interfaces with POSIX. So on a management side, it would be really nice if we can maintain a single code base that's shared across platforms and not just Linux, but also Zephyr. So the POSIX layer is something that is really nice. On top of that, for those who are familiar with Linux, you'd be probably heard of device trees. So device trees are ways to describe what the hardware looks like for Linux. You would describe in a tree-like structure, saying what hardware you have, what chip you're using, what peripherals you have, and basically you compile the device tree configurations into device tree blobs or binaries, and this would be typically stored in your boot partition in your Linux system. And on boot up, that would basically be loaded into your system, and the system would recognize, if you've got that hardware, so let me do that and this. Zephyr also uses device trees. However, it takes a little different approach towards telling the system what hardware we have. So after defining the device tree configurations you have for your particular project, during the compilation, these device tree configurations are actually generated into C header files that describes what hardware you have. And then through the whole compilation process, at the end, you have one single binary that gets flashed into your microcontroller. So all of that, if you look at it, CMake, kconfig for modules, and device trees, POSIX, it's giving a very Linuxy vibe, and that sort of aligns with Zephyr RTOS's goal of becoming the Linux of real-time operating systems. And basically, one thing that we really appreciate throughout the whole product refresh is that it is leveraging standard and widely used tools so that we don't really need to learn like niche tools that's only used in this particular project. And this also explains why the community is so huge for the Zephyr world. So just to summarize all of those points that we just covered, including the abstractions, abstractions between layers, the configurability, the hardware support of off-the-shelf boards, features, sensors, and cross-architecture, we can basically have code that is portable across different architectures and brings the portability that we need for the Dante product into this project. Now, there's other factors. So Dante being more of a networking problem, we rely heavily on the network stack. So one of the selling points of Zephyr is it has native connectivity stacks. So this includes the network TCP/IP stack, the Bluetooth stack, which includes the low energy and the normal Bluetooth stack. And there's also USB stack, which I believe the USB-C stack is a Chrome OS USB-C port where Google has contributed. And this is nice because unlike Zephyr, some other RTOS, such as FreeRTOS, you would need third-party network stack libraries to be introduced to your system, such as LWIP. And having a native stack is more easy to work on. You can cleanly just quickly turn on the use of native network stack through the kconfig and get it running. The Bluetooth and USB stacks are really helpful as well because the modules that we mentioned earlier, the Avios, including the Bluetooth and the USB, is also running microcontroller-based solutions. So eventually, we would really want to move the whole Avio system onto Zephyr as well and use a native Bluetooth and USB stack. Other factors include security. So in the RTOS world, basically, usually you don't have memory management units. So for those who are not familiar, memory management units, or MMU for short, is basically a piece of hardware for you to translate addresses from the virtual address space to physical address space on systems. On smaller platforms, you don't really have that, but on some microcontrollers, you have something called an MPU, which stands for Memory Protection Units. You can think of it as a stripped-down version of an MMU, and the features basically the role it plays is you can define memory regions where you want particular permissions for accessing the regions that you've set. And usually they provide limited regions. So for example, the ARM v7 has 8 regions that you can set, read, write, execution permissions. The V8 of ARM has 16 of those. However, so we really want to use the MPUs and the security aspect of this to really just increase the separation between the execution of applications on the RTOS platform with Dante as well as the Zephyr layer. So just to increase, a little bit of security, yeah. So in terms of RTOS, this is not something new. We thought about it ages ago when we had Ultimo and FreeRTOS. However, we're really looking at what FreeRTOS offers. So FreeRTOS only supports the ARM memory protection units, particularly the V7 and V8. So for the V7, FreeRTOS provides 2 separate ports, one without MPU support, one with MPU support. For V8, I believe that's a compile time option. However, there has been ongoing discoveries over the years where basically people would argue that the FreeRTOS MPU support is basically, flawed by design. So there would be attacks like, privilege escalation attacks where threads can easily increase their privilege priority and basically change the access rights that you have for particular regions to the MPUs. I believe this has been addressed, but over the years, it's only supported on one architecture, which is not nice. Zephyr considers this, and basically these security features are built directly natively into the Zephyr ecosystem, so it makes use of MPUs and MMUs. So MMUs would be the ones on x86 or x64, and although it doesn't provide the functionality of address mapping, but it's basically using an MMU as an MPU, but as well. So having multiple cross-architecture MPU support, Zephyr provides more functionalities, like native stack overflow protection, threat isolation, and it basically just helps us limit the vulnerability attack surface in Dante. And this is something that we really want to leverage in the future. Now, we've covered most of the points on why we selected Zephyr RTOS, and I think one of the most important one is the excitement of having new features. So Zephyr RTOS is very transparent with their project roadmaps. Basically, the state of feature development, where it's at, the blockers, development status, you can basically know just by going to their GitHub and clicking onto their status. And this is nice because we can go into these roadmaps and look at the features that we find interesting and gain inspiration on these features and how we can increase, improve or develop next generation Dante. So some of the ideas that we had, being a more portable platform, we'd really want to run Dante on cross-platforms. So looking at future support for interesting hardware, interesting boards, how low cost can we go? This is one of the ideas. There's also ideas such as running Zephyr on Open AMP, which is in an asymmetrical multi-processing system. Although this is not new, but since it is supported, this is nice. So in this case, this will probably be on a multi-processing processor SoC, where you have a larger Cortex A core that is Linux capable, and a smaller real-time core, either a Cortex M or Cortex R, that we can run Dante on that little core, and leave the more powerful processor for more intensive work for the customers. There's also some interesting features that got released recently. So in Zephyr 3.5, they've introduced something called linkable loadable extensions, where without rebuilding your whole system, you can basically introduce new features and functionalities by providing executable code blobs. And basically that goes back into basically we can put in, let's say, audio confidentiality or cloud connectivity as little plugins and basically introduce it in real time without rebuilding everything. There's also one feature that got released I believe in 3.6, which is link time optimizations. So for those who are not familiar, when you build your real-time operating system binary, you have basically a bunch of code that gets compiled into objects, which later gets linked to one single binary that you flash onto your microcontroller. And basically for Zephyr, you build your objects, it generates the object code for each layer. For example, there's the application layer that gets built into one object blob. The kernel for Zephyr gets built into their own objects. So you get every layer, every subcomponent built into objects, which optimization is done on the object building level. And later on, when you do linking, it then's linked to one single binary. However, with link time optimizations, you can provide to the compiler the link time optimization option, and it would apply the optimizations at the linker level. So the abstractions, abstraction over abstraction, and the overhead that gets introduced in there, and the memory footprint that the additional gore that you have in the abstractions can be taken out and optimized, which makes your binary at the end much smaller, which means you can later on fit more things onto the same binary. So these are really nice features, and looking back, we've really taken a lot out of made use of the Zephyr ecosystem, and basically the low-cost Dante was defined based on what Zephyr offers. However, looking back in 2021, when we were doing the planning, there were a lot of risks that comes with Zephyr RTOS when choosing that, and it was a little bit risky. Internally, we had discussions on whether we should stick with FreeRTOS or move on to a new platform. So Zephyr RTOS, although it was around for more than 20 years, it only really gained traction since joining Linux Foundation in 2016, so it's still seen as a relatively new RTOS player in the field. and which means the vendor support is a bit risky at the time when we were evaluating. However, looking back, I think that has changed a lot over the years, and basically the momentum has really gone up, and a lot of participating vendors and companies are in the project. One of the risk factors is also the talent pool associated with Zephyr. So internally, most of our embedded engineers have familiarity with FreeRTOS, but never really worked on Zephyr projects before. So there's definitely a risk of upskilling our own understanding of Zephyr, and yeah, so that basically takes time. And looking back, there are definitely challenges, and not necessarily addressing all of those, aligning with all of those risks, there are additional challenges that we've also faced. For example, although having a native network stack, it was still maturing. Dante is a networking product, so we're trying to basically send audio through the network stack and trying to squeeze as much audio as possible. So there's no limitations. If your CPU allows, you can basically go up to many channels until it saturates. So when we were trying to develop the prototype of Dante on Zephyr, we are basically also stress testing the TCP IP stack provided by Zephyr. And a lot of issues have emerged. But this was a nice process because we get to engage with the community, fix bugs upstream, and being part of the open sourceness. And this was very different to what we used to work with. So in past times, we would typically just work directly with vendors to solve problems, whereas nowadays with Zephyr, the vendors are participating in the community, and we would be discussing problems directly in community. And Zephyr provides a really organized chat system in Discord. So you would have chat groups for basically your PR for different subsystems and different features. And then you can basically start PR processes on GitHub. We've upstreamed a bunch of different stuff, and you'd see that most of them is related to network stacks. So in particular, we've worked with STM-related, Ethernet-related stuff, and that's also done through Zephyr. There's some miscellaneous statistic reporting, and basically stuff like, stuff didn't align with the RFC standards or the STM data sheets, and having discussions with the community. But, it's not always perfect. And one of the bigger challenges that we faced was the performance bottlenecks that we faced for the network. At the beginning, we were struggling a little bit to squeeze even 2 channels through the network stack. So, and on top of that, there was another layer of challenge which was discovered, which was engaging with the community with the products that we have. How do we share the problems and describe the problems, make the problem reproducible without sharing our code base, what we're doing as a company and our products? Those were some challenges that we faced. And at the end, we took a different approach. Instead of going through the network stack for the audio path, for now we've developed additional implementations of network stack bypass, passing through ring buffers, ring queues to do zero copying to pass forward network packets efficiently, and that worked for us. And yeah, there were discussions for upstreaming these changes, including the network stack bypass, making it more standard. However, this wasn't really really a problem for most people in the community. And yeah, so at the moment, the status for this work is that we haven't successfully upstreamed it. But overall, the community is pretty awesome. Our experience with the Zephyr community is that they're really open to first-time contributors and really just open to helping out and discovering problems and fixing stuff. The Discord chats were very responsive, and the PR process is just really friendly. So that was really nice. One other factor is that, as discussed in the risks, Zephyr is relatively new, and we've realized that mostly in the commercial sense, the industries and the ecosystem is really ramping up over the years, but still getting there. There's a bright future. However, when we also discovered that the talent pool associated with the industry is also not there yet. So there's fewer embedded engineers with Zephyr expertise, And there were features that we wanted to outsource, find experts to work on. And we've looked on smaller freelance sites such as Upwork, and we didn't have much luck. However, if you look at the Zephyr RTOS webpage, they basically list out all the organizations that's offering training, consulting, and services, and who's working on future releases and future features, and you can basically talk to them. So we're quite positive on the support that's coming up on the commercial sense for Zephyr. So lastly, just to wrap up the talk, looking back and looking to the future, in 2024, we've came out with the first solution, the low-cost solution, which is the Dante Pro S1. That's based on Zephyr and the STM32H7. However, we believe that this won't be the first and the only one. So we'll definitely come up with newer Dante on X platforms, not tied to one single microcontroller, and basically leveraging Zephyr's features and portability to roll out more variants. And this is thanks to the portability of Zephyr, the open community, and the openness, the features that helps define next generation Dante. And lastly, I think in the spirit of openness, one thing that we really appreciated and we're really happy about is that throughout this product refresh process, we have more participation in upstreaming than previous projects that we've done. And we expect this to only increase. Thank you very much.
Okay, we have about 3 minutes for questions, so maybe let's just make that one question. Anyone?
Yes.
I know you had to heavily customize FreeRTOS to make it work. Did you have to do much customization of Zephyr to make it work?
So just to align with the fine-grained modularity and clear abstractions between layers, we really tried not to. However, there were some parts that we needed to customize. So, for example, if we go back, one thing for Dante is that time synchronization between devices. And we rely on, I'll probably just stop scrolling, but we really rely on something called PTP, which is Precision Time Protocol, to share the notion of time to each device and basically tune the local time notion to that reference clock. So for PDP, we had to do customizations for the SCM platform, and we're still, so that's the clock domain, the clock configurations at the moment is really customized. I think that's the main part that is dependent on the hardware. So if we move on to a new platform, that's something that we really need to consider. And I think partially in the network stack bypass parts that we've implemented. Yep.
All right, thank you very much.